Hi, we want to take a look at the two problems on the board here. If you look at the one on the left, this is adding fractions, typically taught maybe grade 7, grade 8 in BC. And the one on the far right over there is adding rational expressions, algebra grade 10, grade 11. And the idea is that when you look at the two problems, they look very, very different. And this one here, most people can probably handle. A lot of people look at that one over there and their heads just want to explode and just say, there's no way I can do that. But here's the thing. These are structurally the same problem. They are what we call analogous problems. And this is something that I think we need to take more advantage of when teaching elementary and high school mathematics. Here's what I mean by this. These two problems break down and are solved in exactly the same way. So for example, in this question here, we know that we have 3 of these things that are called fourths, plus 1 of these things that are called sixths. Fourths and sixths are physically different things, so that's why we can't count them together. That's what are we counting? So what do we do? The 4 breaks down to 2 times 2. The 6 breaks down to 2 times 3. And I'm going to color code it, because then when I color code the other one over there, you'll see it as the same structural problem. This denominator is not the same as this denominator, so clearly we can't add the tops yet, because we have to, just like over here, we have to be adding the same types of things together. So what we do is we take this denominator, and this is the grade 9 part, you learn how to factor these things. This is 2 numbers that multiply to 1, but add to give negative 2. So negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. So this breaks down to x minus 1 times x minus 1. This denominator, 2 numbers that multiply to negative 2 and subtract or add, whichever way you want to look at it, to give a positive 1. So positive 2 times negative 1. And that would break down as follows. X minus 1 times x plus 2. So you see structurally, they are exactly the same question. They break down the same way. Continuing, to find the answer to the question now, okay, we're counting factors. We're counting how many factors does it take to make the lowest common denominator. The 4 required 2 2's. The 6 requires only 1 2, and then it requires the 3. So my lowest common denominator for here is going to be the 2 2's, but I needed a 3 as well, plus, and then over here, this denominator, I have a 2 and I have a 3. I require 1 more 2. Once I've counted and put in the missing factors, now I look and I go, okay, what do I need to multiply this denominator by to make it look like this one? Well, I need to multiply it by a 3. If I multiply a 3 into the bottom of the fraction, I need to multiply a 3 into the top of the fraction. That's the skill you'll learn in grade 4 and 5, equivalent fractions. 3 times 3 is 9. What is this denominator missing? If I count the factors, it's got a 2, it's got a 3. It still needs another 2. So I need to multiply this one by a 2. If I multiply a 2 into the bottom, I need to multiply a 2 into the top. So now I have 9 twelfths plus 2 twelfths. 9 of these things called twelfths plus 2 of these things called twelfths is just like 9 cats and 2 cats. 11 cats. They're still cats. That's why we don't add the bottom numbers. I have 11 of these things that are called twelfths. Over here, what is my common denominator? My common denominator is going to be, well, it has to have a pair of x minus 1's. I could write that using an exponent, but I'll just do it like this so you can see it. I still require also an x plus 2. This denominator, I have an x minus 1, I have an x minus 2. And then I look and I say, okay, what am I missing? I'm counting the factors required. I have that, I have that. I still require 1 more x minus 1. So to finish the question then, just like over there, this denominator is missing an x minus 1. Whatever I multiply into the bottom, I multiply into the top. This denominator, is missing an x plus 2 because it's already got these two parts. So whatever I multiply into the bottom, I multiply it into the top. Well, what is this saying? I have 3 of these things called x and 3 of these 2's, so 3x plus 6, plus, so I don't have to worry about any sign changes, 1 of these and 1 of these. So to finish, I have 3 of these things called x plus 1 of these things called x. I can put those together because my denominators are the same. Plus 6, subtract 1. Here I'll use the exponent for brevity. So structurally exactly the same problems, but the idea is that when we get the older kids in the later grades to see that what we're teaching them is the same as something they've learned earlier, they can go, oh, that makes sense. Likewise, on the earlier grades, we want to be able to teach them skills that will translate and extend into the later grades. So for example, the idea here was finding the lowest common denominator, which in grade 5 terms would be finding the lowest common multiple of 4 and 6. So there's multiple ways to do that. There's listing out multiples and then finding the lowest common one. There's using the prime factor method. And there was another one as well, but these are the two main ones that people use, I think. And I'm going to bring the number line down here just to demonstrate. When it says we want the kids to have multiple ways to find the lowest common multiple, we don't want to shortcut it by saying to kids, oh, just use whatever way works for you. We actually do want them to have the multiple ways so that they can use the skills later on. So for example, 4 and 6. I'm going to put out the multiples of 4. So there's 1 4, 2 4s, 3 4s, 4 4s. I'll go up to 5 4s to see I'll go up to 6 4s to see where we go here, because there's a good illustrative point here. Okay, so 6 4s puts us at 24. I'm going to put out the multiples of 6. We know that 4 times 6 is 24, so I'm going to go all the way up to 24. And this is what it will show us. If I just take the two denominators and multiply them together, that will give me a common denominator, but it won't give me the lowest one. And the reason why we, for later grades, don't want them to just multiply them together is because multiplying these two denominators together would be horrendous. And it would make it incredibly mind-boggling to try to work it through and then reduce out the extra factors that we've introduced. When we look at it this way, we can see that, oh, okay, there's no line up here. Okay, there's no line. There, they're lining up. 12 is the lowest common denominator. Okay, so the idea is that they can see 12 is the lowest common denominator, but this method is a good way for them to understand what it is they're doing and what they're looking for. But then we also want them to be able to use the prime factoring method, because that's what's going to extend into Math 10 and 11 later on. All right, so analogous problems. We do this all the time in mathematics. It was a simple thing of like adding cats and dogs is the same as adding fractions. Those are analogous problems as well. Structurally, they are the same, but the surface details look different. And when the kids see this and they get mind-boggled, no, put it into simpler terms for them. 9 cats and 2 cats makes 11 cats. The cats are still cats. Then their minds can kind of reduce their anxiety. They get less distracted. There's fewer details for them to try to focus on. It just makes it easier. So that's why analogous problems are so important in the teaching of mathematics.